Hello, I am E.G. Arcadia Chanda, and this is my calculator app. Now, I have like three files in my calculator app. It's the main file, the XML, and then the controller. So, first is you have the main file, which we just have our main method that launches our uh, our app or something. And then we have your start, which we use our fxml loader, and then we have here the calculator fxml, which is this one, and then this one is for the stage. We basically set the scene and then set the title, and then we show it. So for our scene or fxml, this is just the buttons for the calculator right there, and on all of them we have handle button click, which I have handle button click on all of the buttons. Instead of having like different actions per button, this way I think it's way easier to just have them all in handle button click, and then we use just one method for all of them. I think it makes the code easier to read. So here we have our buttons. We just do those for our buttons. And then here is our handle button click. This is what gets triggered when we press a button. Now, let's actually just run the program right here. So here we have the button. We get the source of it, and then we convert that source into text using this one, get text. Now here, basically, if we click 7, that would get the source of the click button. So this button, this one would be this 7, and then we'll convert that to text, so we'd have a string, and then we'd use that string on our switch. So we now pressed 7, and then here our case, we'd check if we pressed a number, which in this case we did. Here we pressed numbers, so we run this, and then we have an if statement. If it's a 0, it would just set the text of our result. Result here is a label, by the way. This is a label. This is the result. So we would just set the text. So here, if we clear that, it's 0. Then we press 8. That would replace that, because we don't want it to start with like 08. It looks better if it's just 8. And then if it's not a 0, because if that's already 9, we don't want it to be replaced by an 8 when you press 8. We want it to append to it. So we set the text to our custom method label append. I made sorry. I made a method for this because I was gonna use it multiple times, and I think it it would be easier to read if I use this method instead of like uh just manually inputting the append or concatenate. I think it also makes it a bit shorter. So here it appends the result and then the button text. So it takes our current label and then whatever we press this button text, which I've already mentioned here. And then the numbers, and then we have our equal sign here. Actually, I'll discuss that later because it's the final thing that happens in the calculator. Next is we have our operators. You have here, they're all in the side, so it's easier, like our divide, multiply, minus, plus, and modulo. I include modulo. So here we have an if statement. We're checking here if it's not a number right here. And then if it is a number, it just skips that. We have this. So first, let's go over the case that it is a number. So it wouldn't be this, it would be this. We would append our result with our button text, which is this one, whichever we press right there. So let's say I press the plus button, it appends it to the label. Now, if the last character is not a number, and oh, by the way, we use this is number method to check. It is also a custom method right here, is number, which takes the label, converts it to text, and then it checks the last character if it's a digit. If it is, it returns true. If it's not, it returns false. So if it returns false right here, which means we have an operator at the end, and then we press another operator. We do not want that to append to here. We don't want it to be like 982 plus and then a division sign, because that would not make sense. So if we press that, we would replace the last operand, and if we put a number and then we press an operator, it would append it and then replace it. Yeah, you got the point, I guess. And then another method here, label replace last, because it was just easier and shorter to have it in this method. Here it just concatenates it, sort of, without actually using the concatenate method. I think I could have separated this number, label replace, and then label append in like a different class, because they're all for like just checking stuff, but I think it works fine. It wouldn't matter since it's a small program. And then we have here our AC, which is standard for every calculator. It just clears whatever we've written here. There, it's 0. And then delete, we also use our replace last method. So delete, of course, that works just like delete. There. And then our equal sign, probably the most important and most difficult to implement. We now have like 3 plus 3. If we press equal, we can see that one like it executes the operation or something. So 9 times 2, then we press equal, there, 18. Now I actually made it a double right here because we have division. So if we have division like that, we'd see it's like 0.888. If it was an integer, it's just gonna be 0. So for with 6, let's see that 1.5 there. Instead of that, that's gonna show up as 1 if I didn't use a double. So for this equal sign, we use the calculate method right here. Here, calculate, and then we insert our label on our calculate method. So here it is. We first convert it to string, the label. So label get text, and then we separate it in an array. So we have a string array of digits, and then we split it using a regex, and then separates it if it's a digit or an operator, decimal basically. So we initialize the things we need, like current number, result, and then current operator. Now I've made this a plus because I needed to put something in there or else it wouldn't work. Like if I just did this, it would produce an error. So yes, the default is just plus. That doesn't really matter, it gets changed. So here we have a for loop of our string digit, which is this one here. So if this digit, basically one of the entries in our array, matches a decimal, then we would convert it to double first, because this one are int. Well, no, it's a string actually. It's a string, and then we parse it as a double, and then we would apply our operator. So current number, and then apply operator, current number, and then the number, and then our current operator. So we'll discuss the apply operator later, which is here. If it's not a digit, if it's one of these, then we would set our current operator as .1. So let's say it detects a minus sign in our string array, then it would set our current operator to this minus sign, and then yeah, and then sorry, and then after that we'd have like a number. So actually I think it will be easier to explain if I use it on the calculator. Basically 7 minus 9. So first it would separate this, so it will be like a 7, a minus, and a 9. And then here it would detect the first is a digit, so 7. It's gonna convert the 7 into a double, and then we would apply operator. So apply operator basically just takes whatever operator we have and then executes it. Then we have like an if statement here because this is a division and we don't want it to divide by 0. Basically that it's simple. So we have our 7 and then we apply operator. So our current number is 7 or no, our number here is 7 and then the current number is 0 because we initialize it here. And then the current operator is a plus, so it's just 7 plus 0, so it's 7. And then we have here the minus sign, which we would then set as the current operator because it's not this if statement, it's not a number. So it'll be this else if. So, and then after that, we would have the 9, which would be here because it is a digit. So we'd now set that as a double, and then we would apply operator for our current number, which would be 7 now because we did 7 plus 0. We set the current number as 7 plus 0 earlier. It's now 7. Then our number is 9. And then our current operator is a minus, so it will be 7 minus 9. So we'd return the result here as the result, and then we convert that to string so that we could actually use it as a label here, calculate. So yeah, that turns into -2. And that's basically it. All of this operators work. It works with bigger numbers. It works with multiple operations like this. So 9 plus 9 times 2. Well, it doesn't really follow PEMDAS, I think, which could be a problem. But yeah, that's fine. So 9 plus 9 is 18 times 2 be 36. So yeah, it is 36. Doesn't really follow PEMDAS, but it works. You just have to set it yourself. Like it'll be 2 times 9 plus 9, so it follows PEMDAS or something. Doesn't matter. That's all. Thank you.